Okay, so hi everyone. Today we'll understand how exactly LinkedLab library works or how can you use LinkedLab library. So what I've done is I've opened a Jupyter notebook and I've already ran the code so that we don't waste our time while the code runs and finds a similarity. So what exactly is LinkedLab? Let me quickly introduce it to you. So LinkedLabs is basically a Python library which is used to find similarities between any two data frames. Mind it that these data frames should be Python data frames and the features or the columns should be same. So let's directly dive into what exactly is happening in this notebook. So here I've just imported pandas and I've imported LinkedLabs. From LinkedLabs, I've just imported get similarities. And these are my two data frames, df1 and df2, which I've just read. Now, here they have to be pandas data frame. That's what you need to keep in mind. And secondly, my data frames were stored as a pickle file. Therefore, I've used read pickle. You can read Excel, CSV, HDFS, any format that you like, but ultimately your data frame variables should be a pandas data frame variable. Even you can read dictionaries, you can read list, anything, but keep in mind that ultimately you will have to convert them back to pandas data frame. And once you have your data in pandas data frame, then let's just have a look at what exactly do these pandas data frame contain. So the df1 actually contains, so basically this is a data in which you have credit cards. So df1 will contain certain customers which already have credit card with them. And df2 will contain customers which do not have a credit card with them. Now, what is the use case that we are trying to solve here? Well, the use case that we are trying to solve here is, if suppose I am a bank who already has certain customers who have credit card with them, and I have their customer 360-degree view where I have their age, gender, and whatnot. So this example will contain just, this is just an example to illustrate how LinkedLabs works. Therefore, you will see only 5-6 features such as customer age, gender, dependent count, education level, marital status, and so on. So what you'll see is we have only considered 6-7 variables and we haven't considered a lot of variables. But generally, whenever LinkedLab is used, you generally have 2,000, 3,000, 10,000, 50,000 variables which you want to compare against. So again, df1 are customers, but just for the illustration purpose, I've used a very narrow or very small sample with very less features in it. So again, coming back to the data, the df1 that you have, the df1 has customer age, its gender, the number of dependents, what is his education level, marital status, and income category. And then of course, the kind of card which is assigned to that particular guy. Now, df2 are the customers which contain the same columns, except for these guys don't have cards, right? Because these are the customers in this particular bank which actually don't have card with them. Now we need to see that which customers should we assign card to, number one. Okay, so not making it very complicated, we'll just say that, okay, I think, or the algorithm thinks, LinkedLabs algorithm thinks that this particular customer should be given this card. So the cards that we have are blue, silver, you can just have a look at this. Then there are some gold card, etc., credit card as well. But the basic difference is the df2 customers don't have any credit card with them and df1 customers have credit card. Now keep in mind that df1 and df2 should always have same features. Now, because you always compare an apple with an apple. If you compare an apple with an orange, it will not make any sense. The similarities will not make any sense, right? Therefore, what you see is you have customer age, you have their dependents, you have their gender, blah, blah, blah. Everything same, all the features same. This is important because you want to make an apple to apple comparison and not an apple to orange comparison. So that's there. Then I just use the simple one-liner code, single code that I require for to get my similarities. This code is get similarities from df1 and df2. Now it has thrown an error because I have deliberately shown you this because both the columns of the data frame are different, right? Because we have an extra column over here, which is card category, which is not present over here. So it won't be an apple to apples comparison. Therefore, please make sure that your df1 and df2 have the same number of features. Okay, so once that's done, so that's what I have done here. I've just assigned DF, I've just taken DF2 columns and assigned them to DF1, so that now I see that my DF1 columns, these are my DF1 columns and these are my DF2 columns. So I see that my columns are now same. I've just asserted the same thing, that hey, please check whether my columns are same or not. And that's what it is doing over here. Now here, what I've done is I've just taken a random sample from DF1 of 100 rounds. Now, keep in mind that DF1 is the DF from which you want to compare, and DF2 is the DF to which you have to compare, right? So DF1 will be the DF which will contain your credit cards and which will contain the customers which already have credit cards with you, and DF2 will contain the customers on which you want to say that, hey, which credit card should I assign to this particular or give to this particular customer. So now, once we have our column saved, all we need to do is we just need to run this one-liner code, and this code takes care of everything. It takes care of your numerical to feature creation to data cleansing to whatever feature engineering, whatever data cleansing, whatever missing value treatment, whatever it needs to do. It will automatically detect all the data types that are present in your column. It will perform all the analysis that it has to perform. And ultimately, you just have to give this single line of code and you'll get your similarities. So that's how easy, using LinkedLabs is. Now, this will take time. Of course, it takes care of parallel execution and everything, so that you don't have to, wait for a very long time. Since it's a DNA sequencing algorithm. Of course, it is very power hungry, and it might take a lot of time, but it will adjust itself depending upon your CPU counts, your thread counts, your RAM capacity, your processing power, and everything. It will take care of everything. You don't need to worry anything about it. Everything will work under the hood. You just need to write this single line of code, get similarities, and that's it. And it will work for you. And it will do all the wonders for you. So now, if you remember, so now this get similarities will return two data frames, DF1 and DF2. So these will actually be the original data frames, DF1 and DF2 that you have, except for a very slight change that in DF1, you will now have two extra columns. So these two extra columns are best similarity score and best similar with index. So what is the best similarity score? Best similarity score is what is the percentage of matching that it had found? What is the percentage match that it finds similar to? And best similarity with index is with second data frame. With the second data frame, what is the index to which it has matched that particular best similar score to? So what exactly happens under the hood, let me explain you, is each column from DF1, each row from DF1 will be checked sequentially, will be checked with all the rows of DF2. And then ultimately, it will give a best similarity score. Whatever the best it finds in the DF2, it will assign that best row to your DF1. So that is what is happening over here. It is saying that, hey, the best thing that I could find, I found 100% match. So the score will vary from 0 to 1. But it says that I found 100% match of this particular row of DF1 with row number 2888 of DF2. So this is exactly what it is saying. Now let's have a look at 2888. Now I'm just having a look at 2888 and I see that the customer age of DF2 2888 is 44. She's a female and has two dependents and is at a doctorate level, is divorced and has an income less than 40K. So, that's how it finds similarity. Now, under the hood, it uses DNA sequencing algorithm, but you don't have to worry about that. All you need to worry is what is the best similarity score that it is getting and what is the index best similarity with index that it is matching. You can directly do a iLog on the second DF and get your result out of it. So now, if I have if I have if this particular person has a credit card, or I want to assign a credit card to this particular person, I can directly say that, hey, it matches to this particular person, and please, whatever credit card was assigned or given to this particular female, just assign that category, that credit card to this female as well. So that's how this works. Thank you for your time. And if you need anything, you can always reach us out at hello@linklabs.com. Thank you.